Alrighty. So let's start 1.5. It's essentially what we were doing before in 1.4, solving quadratic equations. It's just that the equations are created with something happening in real life. Like, for example, area of a rectangle. We know area is length times width. When you multiply length times width, you get a square, right? Quadratic, especially if it's in general terms. In physics, we have like falling problems or things that you throw up in the air. They kind of have that parabolic shape, right? It goes up and then down, hence parabola or quadratic equation. So we're gonna solve these, but most of these are kind of already set up. Number one, we gotta write the equation down, figure it out. Number two, we gotta is practicing with decimal numbers, so we got to use our calculators. Three, is probably something similar. We'll see. Maybe we'll graph it. But yeah, that's the idea. So let's get started. All right, so 1.5, again, what we're saying is just quadratic equations, but they're applied to something. So word problems, etc. But the solving part is all the same as 1.4. It's just that you got to create the equation to solve. So remember, if you don't know, look it up. I believe that you remember the area of a rectangle, right? Area is equal to length times width, right? They told us that the area of the rectangle is 44 yards. So that means that A is 44 yards squared. Area should always be square units, right? Like square feet in an apartment or a house. Now they say, and the length of the rectangle is 3 yards less than double the width. I'm like, okay, that sounds super weird. But when I hear the word is, that's an equals, right? Remember, word problem strategy. Length is 3 yards less than double the width. Oh wait, so less than means I'm subtracting from it. So it would be it would be double the width minus 3 yards. We'll just keep it at three and understand that this will all be in yards. Okay. Now, if we were to solve for width, I don't think we need to. Yeah, this is what we're gonna do. We're gonna plug in area and length into here and have everything in terms of W, which is width. Okay. All right. So we know that I'm not gonna write the yards. I mean, I probably should, but just so it's not so messy, plug in the L, plug in the A. All right. So here's my L. Here's my A. So 44 is equal to 2. So distribute your W, right? W times 2W, W times -3. Here we go. Solve. Now we have a quadratic equation, which is where we wanted, right? We created a quadratic using this information. Okay, so in all honesty, that's the hardest part. Word problem is just trying to translate it and getting the problem set up. Because once we're here, we're back to solving quadratics, right? So we're going to move that 44 over. In other words, set it to 0, subtract 44. Does that factor pretty? I don't know if it does. Let me check before we get all messy. Yeah, I think for word problems, you should just most of the time, when the numbers are kind of big, I'd say just go for the quadratic equation, right? So my A is 2, my B is -3, my C was -44. Okay. So W is equal to negative b plus or minus square root b squared minus 4ac divided by 2a. So that'll be negative 3 plus or minus square root of negative 3 squared minus 4 times a times c all over 2 times a. All right, so let's do some calculator stuff, make it a little prettier. And so I'm just going to do the inside here, so that'll be negative 3 squared is 9 minus 4 times 2 times um, negative 44. There'll be 361 inside. Okay. Double check. 9 minus 4 times 2 times, yeah, okay. Positive 3 plus or minus 361 over 4. Can I square root? I think you can. 361. Yeah, this is 19. Surprisingly, this is a little prettier than I thought it was going to be. So this implies, and put an implication arrow, that W is equal to 3 plus 19 over 4, or N, yeah, that's going to be both. W is equal to 3 minus 19 over 4, which will give us 21, wait, no, 22 over 4, which is 11 over 2. This would be negative 16 over 4, which is negative 4, right? Yeah, two answers. No, don't forget what are we doing, right? Let's not get lost in the weeds here. We're solving for the dimensions of the rectangle. Does it make sense to have a negative width? It does not. So it has to be this one. So if with, well, we can just go back here, right? And move this a little, move this over. Don't have to use another page. We found that W is equal to 11 halves, which is what? 5.5. So plug in 11 halves, so that would be 2 times 11 halves minus 3. That would be 2 times these would cancel. 11 minus 3 would be 8. So length is 8, width is 11 halves. So we found the two dimensions. So this is what they wanted. And I'll put my quadratic stuff up here. A was 2, B was negative 3, and C was negative 44. Okay. So from the top, it says area of a rectangle, so I wrote down the area of the rectangle formula. They gave us A, area. Plug that in. They told me that the rectangle had a length that was 3 less than 2 times the width. 3 less than double the width. 2 times the width minus 3. Double the width, less than 3. Right. Plug that in, have everything in terms of one variable, because once you have one variable, one equation, you can solve for width. And that's what we did with the quadratic formula. But quadratic formulas tend to give you, not always, give you two answers. You need to pick the one that makes sense. Pick the 11 halves because it's positive. Negative dimension doesn't make sense for a width. And that's it. Once you have that, plug it into the length, and now you have length. Because they told us what the length was, right? 2W minus 3. All right, let's go on to the next one. I'm gonna skip number two because it's just using the quadratic formula and then rounding, so it's just a calculator question. Let's move on to three. All right. So number three is a word problem, but they give us the equation actually, so it's not that hard. We just gotta understand what they're asking. Um, a ball is thrown from a height of 151 feet, okay, with an initial downward velocity of 15 feet per second. The ball's height in h, oh sorry, the ball height h in feet after t seconds is given by the following formula. So they already made everything for us. All we gotta do is answer the question, how long after the ball is thrown does it take to hit the ground? So if we assume that the ground is 0 feet, right, which we should, set it equal to zero and solve for t. And we should get two different times, which would make sense. But let's see. Let's see what happens. So plug in zero. These are my t's. They don't look very good. I'm going to move everything to the left-hand side just because I want this to be positive. Doesn't that way I can use the quadratic form like I always do. I don't think you have to. Pretty sure you don't. So A is 16 now that I moved it over. B is 15. C is negative 151. Okay. So solve for t. The quadratic formula says your variable will be equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a. Okay. Sorry, so under the weather here. Okay, so that'll be negative 15 plus or minus square root 15 squared minus 4ac. Oops, sorry. A was 16 times negative 151. There we go. Okay. I'm going to try to make it a little prettier. So 15 squared, double check everything. B, A, C. Signs are good. Negative B. Yeah, okay. Let me do the inside first. Okay, so that'll be, I'll put it over here. Negative 15 plus or minus the square root of 9,889 divided by 32. Okay. At this point, just plug in your calculator, the plus and minus version, because they want it to round anyway, so we don't need exact answers. So if you're going to do fraction, do the top part parentheses, right? That'll be negative 15, use the negative symbol, not the minus symbol, plus the square root, 9,889, divided by 32. And then do it again with the minus. This is negative time, so we should use this other one. And this is round to the nearest thousandth, so tenth, hundredth, thousandth. Look to the right, so that'd be it's 2.639. So this is roughly, we're only going to use this one, 2.639. So that's how long it takes to hit the ground, the ball. We set it equal to zero. We found the time when height is zero. All right, that's all we did. Zero, formula, calculator. Okay, number four, similar to the first one we did, but we have to create the equation. So let's get started. So the length of a rectangle is 7 yards more than twice the width. Okay, so remember the sorry, area is equal to L times W. And they're giving us the area of 555 yards squared. So write the equation. Length of the rectangle is 7 yards more than twice the width. So 7 plus 2W, or 2W plus 7. Plug that in, and we'll have our formula. So that will be a little arrow here. That will be 555 equal to 2W plus 7 times W. So that will give us the equation of 555 equal to 2W squared plus 7W, right? Distribute your W. Here we plugged in the L, and now we're good. So we can set it to 0 for fun, but we're pretty much done. There's my quadratic equation. Okay, so now part B, they want us to solve for width. So part A, you kind of get the equation in terms of one variable using the substitution and start solving. Okay, so we're going to solve this guy. So we need A equal to 2, B equal to 7, and C equal to negative 555. All right. So quadratic formula time. W will be equal to negative B plus or minus square root of B squared minus 4AC, the whole thing divided by 2A. That will be negative 7 plus or minus the square root of 7 squared minus 4 times A times C. All right, so this point is just use your calculator. Um, Make this a little prettier. He's about to die. So 49 minus 4 times 2 times negative 55 or 555, 48, 40, 89. So that'll be negative 7 plus or minus square root 4489 over 4. Does that have a nice square root? I think it does. Yeah, 67. So this square root of this is 67. So this would be negative 7 plus or minus 67 over 4. So W will equal -7 plus 67, or W will equal -7 minus 67. Both over 4, of course. What is that? -7 plus 67, obviously 60 divided by 4, which should be 15. Yes. -67 minus 7 divided by 4 is -18.5, which is as a fraction. Oops. I forgot how to do that. Oh well. Mhm. Now we're going to take the positive, obviously. Negative with, don't need that. Doesn't make sense. So we solved part B. This is what they want. Part C says solve for the length. So length was said was 2 times the width plus 7, which is equal to 2 times 15 plus 7, which is 37. Now everything is in yards. So yards, yards. Okay. So part A was uses information to create your formula. Create the formula just like number one. Part B is, or part A, I guess, uh, solve for the width because you gotta get it all in terms of one variable, which is what we did. Once you do that, you can use a quadratic formula to find your width. Once you have width, plug that into the length and you'll get length. Okay. Now number 5 is pretty much the same thing, so let's move on. Hmm, 6 is kind of weird. We'll do 6 and then I'll leave the rest to you. The rest are the same, they're just harder, a little different. 6 is just very different. Okay, so we're gonna end up with a quadratic once we set it up. It says write an equation representing the fact that the product of two consecutive odd integers is 255. So you kind of have to have a formula to understand something that's always odd. Like we understand that if it has a multiple of 2, it's going to be even. Like for example, if I have 5, which is odd, but I multiply it by 2, it's now even. 9 is odd, but if I multiply it by 2, it's now even. So that means that 2 times any number will always be even. But if I were to add 1 to any of these numbers, it would go back to odd. So if I take that first one and add 1, it's odd again. If I add 1 to the 18, it's odd again. So the formula that you need is this. 2n plus 1 is an odd number. So that means that's where we need to start. Because it says write an equation. Let's use x. It said to use x in the problem. So consecutive means the next one right next to each other, right? So if it's 3, the first odd number is 3, then the next one has to be 5. If the odd number is 9, then the next one has to be 11. So it needs to be 2 over. So first odd is 2x plus 1. the next one, consecutive odd, is 2x plus 3, because if the next thing would be even, so I would need the one right after. So if we're at, let's say, 5, I would need to go two more to get to 7. So those would be consecutive, so it would have to be two more. So that's how I came up with this. So this means it's always, no matter what x I choose, it's going to become odd. This thing would be the next odd number. Okay, so these kind of this formula is something you need to kind of remember. This is just a general odd number. 2 times x will always be some even number. Okay, that's a little strange. So it says what? The product of two consecutive odd integers is 255. This is something I wrote. This is not part of the problem. So that means that the first one, I don't know what it is, times the next one has to be 255. Okay. So now we have our formula set up. So that's part A. Part B, solve the quadratic. Right. So multiply this out, we're going to get some stuff. 2x times 2x, 2x times 3, 1 times 2x, 1 times 3. Combine all these together. Now we have a quadratic equation. So subtract that over because you can't solve a quadratic until you set it to 0. So that'll be minus 255. That'll be negative 252, right? I subtract 255 on both sides. Yeah, to solve this guy. And look, they're all even. Could divide everything by 2. Or factor out of 2, however you want to think about it. Since they are all even, you can make it smaller. This would become 2x squared plus 4x, 252 divided by 2 out of paranoia. We know we should know that answer. It's one of the special numbers. Okay, so there we go. So now we can factor. Oh, they're still even. Dang it. Well, that's a good thing. I just didn't catch it. Divide everything by 2 again. I'm not going to show it this time. Um, that's going to be what, 63, right? Yes. Okay. Now factor it. Should factor pretty because they're whole numbers, consecutive integers. So they got to be. That's another clue I forgot to mention. The odd and the integer part is what let me use this. Okay. So now I'm going to get nice, pretty numbers. So factors of 63 that add up to 2. Don't know what that is. 3 and no. Oh, yeah. Silly. 9 and 7, right? So x will be these two things. So x is negative 9, x is 7. So we found x, but what is x? It's not what we're looking for, right? We solved the equation that's going to help us find the two consecutive numbers. So we got to plug this into here. So part C, find the two consecutive odd numbers. All right, so um, using x equal to, we said 7, right? Yeah, 7. So the first one we said was 2x plus 1, so that means it's 2 times 7 plus 1, which will be 2 times that's 14, that's 15. The next consecutive has to be 17, but let's use our formula so you can see it. Even though we know consecutive would be the next one, the next odd number. 2 times 7 plus 3, that'll be 14 plus 3, which is 17. So there's our two answers. First and second consecutive odd numbers. Given that their product is 255, product must be, and of course it is because we created the equation with that information to solve for x, which will then give us the two numbers. Okay? But anyway, so section, that'll be it for this section. 1.5 is just different applications. There's many applications for quadratics, but at the end of the day, all you're doing is factoring, quadratic formula, solving for x. It's just how do we find that equation? That'll depend on the problem and what's given. But the work is the same, the algebra is the same, but the solving and the thinking will change. That setup will change. Okay. All right. Let's go to the next section.